Here's your text organized into paragraphs without missing any words. The universe is enormous, and our solar system is only a tiny part of it. The breadth of the initial photos from the James Webb Telescope and the interstellar travels of Voyager 1 and 2 show that the universe is vast beyond the solar system. However, the heliopause has recently suffered many terrifying changes, and it appears that something is attempting to enter our solar system from interstellar space. Today's video will discuss the alarming new threat found by the James Webb Telescope as it approaches our solar system. The heliopause is the boundary between the solar system and the interstellar medium. The heliopause is the boundary between our solar system and the rest of the universe. Therefore, shifts in the heliopause are of particular interest to researchers at Long Peak. Our current heliopause models don't account for certain terrifying changes that new research suggests. The alterations were uncovered through a review of data collected by NASA's Interstellar Border Explorer, IBEX. According to specialists, the heliopause was detected by LAXIT after the satellite picked up a series of increasingly energetic neutral atoms. Moreover, you are correct. This is a major development. Further, the heliopause has shifted, as seen in the data from Voyager 1 and 2. Moreover, scientists found that the heliopause changed so drastically between the time Voyager 1 and Voyager 2 entered interstellar space that it directly conflicts with our present understanding of the solar system's outer boundary. These sudden changes could also explain why the two probes are separated by such a large margin as they enter the interstellar medium. In October 2022, researchers wrapped up the paper on the topic, publishing it in Nature Astronomy. In it, they outlined how the scenario would evolve and categorized the heliopause adjustments as potentially controversial. Therefore, they plan to continue exploring the farthest reaches of our solar system with NASA's Interstellar Mapping and Acceleration Probe to get a more in-depth knowledge of interstellar space and a better grasp on these alterations. Scientists, however, will need to make do with the information we already have and the results from spacecraft like the Voyager probes and the James Webb Space Telescope. But have you ever given any thought to how the heliopause was first discovered? If you don't know the background, we'll fill you in. Once the heliosphere was discovered in the early 1950s, the heliopause was a natural consequence of the space age's dawn. Once the heliosphere was proven to exist by satellite data, physics models of its interaction with the interstellar medium showed without a doubt that the heliopause must exist somewhere. Pioneer 10 and Pioneer 11 are the most likely candidates for the earliest spacecraft. As a result, evidence for the heliopause has begun to emerge. Years of data on solar wind activity have been gathered by the Pioneer probes since their 1972 launch. Since then, almost $67 away, Pioneer 10 sent its final coherent signal back to Earth in January 2003. In 1993, however, data from the Voyager spacecraft confirmed the existence of the heliopause with greater certainty. In addition to providing the first direct evidence of a definable boundary with interstellar space, the two probes were in a privileged position in the interstellar medium to detect strong low-frequency radio waves generated by the violent interaction between intense solar winds produced in May and June 1992 in the interstellar medium. The discovery that galactic cosmic rays had increased while solar wind particles had decreased was made by Voyager 1. The most convincing evidence for the heliopause existence came in 2012. The signal proved that Voyager 1 had entered interstellar space. Despite the seemingly clear evidence, the anomaly wasn't isolated to Voyager 1. In 2018, Voyager 2, which is on a far different trajectory than Voyager 1, saw the same rapid drop in solar wind particles and spiking galactic ray particles. Let's discuss what an asymmetric heliopause actually is and why scientists are so worried about it. A good analogy for the heliopause, if we are to conceive of it as a boundary, would be a windsock that is continually being stretched and blown outward by the wind. Let's assume that this is the shape of the heliopause from a purely physical standpoint. A comet that is nearing the Sun and is generated from the sublimation of gases surrounding the comet's core is another close approximation, and that's how the heliopause appears in your mind's eye. This means that the heliopause has a specific form that happens when the solar wind collides with the interstellar gas and magnetic fields outside the heliosphere, which exert an opposite force. In addition to the force of the interstellar wind on the heliosphere, the reversal of the Sun's magnetic field polarity throughout the course of the solar cycle contributes significantly to the shape of the heliopause. When the solar wind pushes up against the interstellar wind, it causes a three-dimensional sine waveform in the solar wind, which in turn affects the formation of the heliosphere and heliopause. The only artificial objects known to have entered interstellar space so far are the Voyager probes, which crossed the heliopause in 2012 and 2018, respectively. Their observations were critical in establishing the existence of the heliopause, but it is evidence that a system consisting of only two sensors cannot accurately detect a three-dimensional structure in space. However, what we should be worried about is the asymmetry of the heliopause, which might lead to an invasion of extraterrestrial life. While it's obvious that interstellar space lies beyond the heliopause, much more regarding the heliopause and what lies beyond is still unknown and up for debate. For a long time, scientists have speculated about the existence of a bow shock just beyond the heliopause, where solar wind particles and the heliosphere's magnetic field disrupt but do not completely overwhelm the interstellar medium in front of them. The theory of a softer bow wave has gained acceptance due to the contention that the solar system is not moving swiftly enough over the interstellar medium to cause a shock. The ibex ribbon is a band of intense ENAs that extends along the heliosphere and is notably brighter than the neighboring ENAs, presenting a contrast. Nonetheless, no one has yet provided a satisfactory explanation for the occurrence of the ibex ribbon or its implications for current heliopause models. A research student at the Southwest Research Institute named Justina Sol has argued that the Sun is similar to billions of other stars in the universe, suggesting that some of those stars have atrophy like the heliosphere. However, this atrophy is one that we can observe closely because we are truly inside it. Consequently, we need to fill in our knowledge gaps regarding the local area before expanding our horizons to the rest of the universe. However, imagine a world where there is no heliopause to protect humanity. So then, what? We humans are ridiculously fortunate to have that solar windshield. The heliosphere, which the Sun provides, absorbs 70% of the interplanetary cosmic rays. Without the heliosphere, cosmic rays would collide with Earth, interacting with it in a way that would greatly increase the radiation we absorb, frying life on the planet like eggs in a pan. To the contrary, it is not known how challenging this wall of hot plasma will make interstellar travel if and when we decide to journey beyond Mars and finally exit our solar system. Even so, considering that Voyager 1 and 2 arrived safely, at least our interstellar ships don't look like they take too much of a hit. We don't know how the plasma wall will affect living beings like us. Thus, this is a topic for further discussion. Thanks for watching. Leave us a like and subscribe to our channel to make sure you don't miss out on any news about the James Webb Space Telescope. Also, we have another video ready for you. Click on the video on your screen and let us take you on to another space adventure.